Good morning, students. So, today's class we are going to study about the ECG classification, that is normal versus ectopic beats. So, if you see for any kind of classification, we have to need to extract the features. So, the features will be given as an input to the classifier so that we can able to classify the two different signals based on the features. So here in the case of ECG, the features which is used for classification is two different features. One is form factor, another one is R2R interval. So form factor, it is calculated by using some mathematical expressions. So I will show you in the forthcoming slides. So if you see the form factor, that is a very suitable measure to discriminate the normal and the ectopic beats. And you know the R2R interval, the time interval between the R wave of one cycle of the ECG to the next R wave of second cycle of ECG, we call it as R2R interval. And if there is any variation in the R2R interval, it leads to sinus arrhythmia or some kind of an arrhythmia. So if you see this particular picture, this is an ECG waveform in which the R2R interval and the form factor, so they have calculated and the values are displayed here. So this is an ECG waveform of an 65-year-old male patient who is having ectopic beat. So if you see the how to calculate the form factor, so the form factor it is calculated here by using this formula mx dash divided by mx. So which is nothing but it is like mobility of the first derivative to the mobility of the signal itself. So if you see the form factor, it is an indication of variance of signal activity. So that is called form factor. The activity of the signal, it is calculated here as mx. So which is defined here as square root of activity of the first derivative of the signal to the square root of the original signal. And the form factor is again, it is calculated by using the mathematical formula mx dash divided by mx. So that means the ratio of mobility of the first derivative of the signal to the mobility of the signal itself. Then if you see the significance of the form factor, so this form factor it is used to isolate the premature ventricular contraction beats from the other beats. Then if you see the form factor of each wave between the two consecutive R interval R peak is computed, and if there is an very erratic nature of the PVC beat, that will increase the complexity of the signal, thereby increasing the form factor value. So if you see this particular picture, the ECG waveform of patient, so they used to apply the Pan-Tompkins algorithm and detect the QRS detection from the ECG signal, and then to each beat it is segmented at a point from 160 milliseconds before and 240 milliseconds after the detected marker points, and then you can able to see that the diamond and the circle shape is given, symbols are presented in the ECG. So they calculate the form factor and the R2R interval, it is calculated here. So this is an ECG signal of a patient with an ectopic beats. So you can able to see that in that waveform there is a bigeminy is there. Bigeminy means the alternative normal beats and PVC. So here the normal waveform it is represented by O, and the abnormal waveforms like PVC it is represented by X. So in these waveforms you can able to see there are 4 cycles of normal ECG followed by a PVC, and 5 cycles of normal ECG followed by PVC like that. So in this if you see bigeminy there are 2 normal cycles followed by what we called as PVC, and again normal PVC, then normals etc. So like that the ectopic beats are represented in this ECG signal. So now what is the procedure to classify the normal versus ectopic beats are? So first of all you have to detect the signal, compute the features, and then develop a pattern classification rule. So first of all the signal should be filtered with a Butterworth low pass filter whose cutoff frequency varies between 70 Hz. And the order of the filter is 8. The sampling rate is used is 200 Hz. Then Pan-Tompkins algorithm is applied to detect the QRS complex from the ECG signal. So here the QRS T portion of the each beat, first it is segmented between the interval 160 milliseconds and 240 milliseconds after the peak. So then they calculate the R2R interval and form factor. So when they calculate these two features, R2R interval and form factor, the vectors are represented for normal is 0.66, 1.58. For PVC, the vector, pitch vector is represented by 0.45, 2.74. So when you see a decision line or a decision function which discriminates the normal and ectopic beats, which is given by the equation R2R minus 5.56 into form factor plus 11.44 equal to 0. So the decision rule is, if this particular equation is greater than 0, then we call it as normal beat. When it is less than or equal to 0, then we call it as premature ventricular contraction. So if you see the feature vector, so it is plotted R2R interval versus the form factor. So all the signals are plotted here. The O represents the normal and the X represents the PVC. And this line is a decision line which discriminates the normal and as well as PVC. So in this you can able to see only the normal signals are located below the line and only the PVCs are located above the line. So the two groups are equally properly it is separated. Thank you.